Okay, hello everyone. Okay, so here we have another infinite pulley system video, right? Looking at the question, this is what our question is. We have a sequence of pulleys on one side of a large pulley, right, where masses are m and then 2m and then 4m and then 8m and so on. On the other side, we have the normal question in which we have masses m and so on till infinite, right? We have infinite pulleys on each side. One side we have masses of m, and other side we have m, then 2m, then 4m, then 8m, so on. What we have to find is we have to find acceleration of each pulley, we have to find acceleration of each mass. That is, once we get tension in the string, in any one of the strings, then we can find the acceleration of each and every block, because if tension is t here, in this string it will be t by 2, and here it will be t by 4, here it will be t by 8, and so on, right? Now to solve this question, we will do it in terms of effective mass method, which I have discussed in the infinite pulley system first video, right? So if you have not watched it, please make sure you watch that particular video, then come to this question. I'm sharing the link in the description. All right. So what effectively we have here is we have this whole kind of system on the left side and another infinite pulley kind of system on the right side. We have to find, say, tension in any of the string or and acceleration in of any of the body. All right. तो चलिए देखते हैं फिर यहाँ पे. Let me study the question very quickly. Consider an infinite pulley system as shown in the figure. All pulleys and strings involved are ideal. Given system is released from rest, then choose the correct options. All right. So again, I'm doing a very quick recap of that output machine scenario where suppose I have this fixed pulley. On the right, I have mass m1. On the left, I have mass m2, right? We have already seen this. In this particular case, the acceleration will be of any block. Suppose m2 is heavier, the acceleration will be m2 minus m1 upon m1 plus m2 into g. The tension in this particular string, equations you know, right? The equation of this block will be T minus m1g is equal to m1a. The equation for this block will be m2g minus T equal to m2a. And all that, you get this acceleration in this string, you'll get the tension as 2m1 m2 upon m1 plus m2 into g. And what is the effective tension here? Yeah, effective weight here, this tension, that is 4 twice of this, right? Twice of T, that is 4 times m1 m2 upon m1 plus m2 into g. All this we have already discussed in the previous video, right? So if this particular pulley is at rest, I can say that effectively the system has a mass m effective of what? 4 m1 m2 upon m1 plus m2. And if the pulley is at rest, then effective g is g. If this system is in an accelerating frame, then effective g will be g plus or minus a to find this particular tension, right? So that is what we'll be using here again. Okay, now what we have in this particular question, keeping this in mind, this part, that is m effective is 4 m1 m2 upon m1 plus m2, or we have also seen something like this. 4 by m effective is 1 by m1 plus 1 by m2. This part also we have already done in the previous video. So make sure you look at that video also. Right now in our question, what we have on the left side, we have a sequence of pulleys of increasing masses, right? M, then 2m, then 4m, then 8m. And on the right side, we have all these blocks connected to pulleys of each of mass n, right? So what I can take this whole system effectively as, that is what I have to think here, right? What I will say is, let me say whatever this acceleration is, it doesn't matter. I would say this whole system has an effective mass m effective. M1 is m and the other m2 is this whole thing, right? So look at this particular part, right? I'm saying this whole system has a mass of m effective. We have already discussed this part. So can write something like this: 4 by m effective here is equal to 1 by m1. M1 is what? M, small m, plus 1 by m2. Look at m2. What do we have here? Right? Again, this whole similar system, right? This is the thing. I'm taking this whole system as m effective, right? Mass of this whole system as m effective. what is this particular thing equal to? This is again the same thing. Have infinite pulleys, each connected to a mass of each of mass m, right? So this is again what this m2 is again what m effective itself. So I have 1 by m effective. So from here I get 3 by m effective is equal to 1 by m. M effective is 3. Okay. All right. We have already done this part previously. Now, looking at the other side, right? We have reduced this instead of this whole part for finding tension here or here. I can replace this whole system with a mass of effectively 3m, right? Because this pulley is fixed. And I can solve for it and we'll do that later. But let me see how I will reduce this particular section of this particular pulley system as, right? So what I have here is I have continuous masses which are increasing from m, then 2m, then 4m, then 8m, so on, 16m, so on till infinity, right? Again, this whole system's effective mass, let me consider m effective. Again, I'll write the equation 4 by m effective is equal to 1 by m1. M1 here is again m, 1 by m plus. Now look at the other side of this particular pulley, right? This is m1 and this whole thing is m2, effectively m2. Okay, now look at this thing. Can I say if this whole system has effectively finding tension, all that, if I take this mass as m effective, right, in which what do I have? I have masses, blocks of mass m, then 2m, then 4m, right? Now, effective mass 4 by m effective is 1 by m, m1 is m. The second m2 part, look at this. Again, I have an infinite system, blocks, instead of m, the starting mass is 2m. The next thing is 4m, then the next thing is 8m. So can I again say of this, again, what I have is infinite masses on the left side, and every mass has been doubled compared to the original system, right? So effectively, my m2, what will this m2 be? M2 will be equal to 2m effective, right? Because each and every mass compared to this system of infinite masses and infinite pulleys, what I have here is again the same kind of system, but every mass has been doubled, right? There the sequence was from m, 2m, 4m, 8m. Here what has it become? It is starting from 2m, then 4m, then 8m. That means every mass has been doubled here. That is my effective mass. I have to take that as 2m effective, right? So my m1 is m, m2 is this whole system will effectively behave as a mass equivalent to 2m effective, right? All right. So from here, let me get my m effective. This will be 4 by m effective minus 1 by 2m effective is equal to 1 by m. 8 minus 1, that will be 7. So my effective mass will be 7m upon 2, right? That's it. Our problem is done. So for finding tension, what I can do is I can replace this whole section of pulleys and masses as equivalently equal to 7m by 2. Right? So what I can do here is I will reduce this system to something like this. On the left side, I have equivalent mass of 7m by 2 effectively. And on the right side, what do I have? Effective mass of 3m, right? So to find tension, I can directly use the simple Atwood machines formula. What will be the acceleration of say this is pulley P1 and pulley P2, right? So instead of pulley P1 or effectively this whole system, I have replaced it with a 7m by 2 mass, and here I have replaced it with a 3m mass, right? So which will come down. Obviously, we have heavier masses on this side. Obviously, this section will come down. Let us say acceleration is a, this will have the same acceleration a upward. So what will be the accelerations of pulleys P1 and P2? That will be 7m by 2 minus 3m upon 7m by 2 plus 3m into g. That is effectively how much? 1 by 13. 7 plus 6 is 13 into g. Right, this is the acceleration each of pulley P1 and pulley P2. Right. How about the tension here? What will be the tension in this particular pulley which is at rest? Actually, that tension, again we know that is 4m1 m2 upon M1 plus M2 into G. So this effective tension, once I get this tension, I can get this tension and this tension and this tension, every tension, right? Every tension and everything I can get, and I can get the acceleration of each and every block here, right? So what I will do is I'll find this tension and our problem is done. So that tension effective will be what? 4M1. What is effective M1 here? 7M by 2. Effective M2 is 3M, right? The tension in this particular, the topmost string, that will be 4M1 M2 upon M1 plus M2, M1 plus M2 into that pulley is at rest, right? G effective is still G. So this will be my tension. Once I've gotten this tension, once I get this tension, I can find tension in each and every string, and I can also get the acceleration of any block which we want, right? All right, hope you have enjoyed the video. Please do like and subscribe. See you in the next video. Bye-bye.